In this use case, I consider a U-shaped warehouse where there is a receival area from which cargo is put away into one of the automatic storage and retrieval systems. There are 3 in total considered in this use case. And then there's a shipping process. So it's U-shaped in the sense that material goes in at receival, then is put away in the storage area, which is one of the ASRS systems, and then the retrieval for the shipping process takes place from the same ASRS system and is transported towards the shipping process. This internal transport from receival to storage and from storage to shipping is facilitated by means of AGVs, and that is what is mainly simulated in this use case using the framework used for this use case. So you can use this project to simulate the AGVs in terms of their throughput and utilization, and also the associated processes. So here in this case, the receival process point, the ASRS process points, and the shipping process point. For each process point, you assume that this is represented by one, so to say, process equipment. So, for example, at the ASRS process point, you could say this process point represents the process point of an ISRS machine that puts away the cargo and retrieves the next cargo. And at receival and shipping process points, the equipment could be, for example, a forklift that is represented by this process point. A forklift that picks the cargo from the AGV and puts it into the truck, or places the cargo onto the AGV from the truck. In terms of the assumed AGV cycles, the AGV is always driving this circle. They queue at the shipping and at the receiver process in a FIFO queue, so first in, first out. And when they receive cargo from the receival process, they select one of the automatic storage and retrieval systems, where they then also queue and are processed by the process point, so representing the ASRS machine. The process point, well, in terms of the cycle here at the ASRS process point, it's assumed that the AGV puts away cargo and retrieves cargo. So the ASRS machine picks the cargo, places it somewhere in the ASRS system, and places the retrieved cargo for the shipping process. And the AGV then, once it has received the retrieval cargo, then moves to the shipping process, queues at the shipping process until it's processed by the shipping process point. And then it returns to the idle point, which is between shipping and receival, and waits for a receival order. Once it receives a receival order, it moves to the receival process point and queues there, where the AGV is also processed first in, first out. There's also documentation here, so you can see the project content here. You can see there is a framework file that provides a framework for the relevant process points for the AGVs, and for also data collection and statistics. Then there's a configuration file where you can adjust certain parameters. You can also use the framework with the attributes provided there for the respective classes to conduct parametrization in your implementation. The material flows are implemented in the model file, and the running model, so to say, just parameterizing it and kicking off the simulation and generating the visualization, that is done in the main file. For the visualization, the tools module provides standardized visualization functions for visualizing the state distribution of the AGVs and the process points, and also the throughput. And in the docs file, there's then a documentation, which you can see here, which is just showing an exemplary use case, which is this layout that I just went through. It documents the parameters that can be adjusted in the configuration files, for example, speed of the AGV or number of AGVs, the time per AGV turn, and also, for example, interchange times and what I call after interchange times. So, for example, when we consider the shipping process, the interchange time is the time it takes for the forklift to pick the cargo from the AGV, and then the after interchange time is the time it takes for the forklift to bring away the cargo into the truck and return to the process point. So for all these values, you can adjust in the configuration file, and then the framework itself for the respective classes, you can of course also use the constructor to conduct parametrization. So here the arguments are the positions of the AGV, the initial position of the AGV, the fixed position of the process points, the IDs. So you can give an ID number to each of these instances. And then you can, for a process point, specify whether it's a loading operation or unloading operation or both. And you can also specify the respective times. For the AGVs, you can, for example, also specify the idle position. So each AGV can have a list of idle positions, and then it chooses the nearest idle position when it doesn't have jobs and drives to this idle position. Okay. So here's then a documentation, an example of how to implement this exemplary use case of this U-shaped warehouse. You can see that on these slides. And then here you can see the default statistics visualization is provided by the tools module contained by this project. And yeah, that's basically it. So yeah, I hope you will find it useful. You can find this in the shop on my blog, Supply Chain Data Analytics, where you can download it and use it as a template and for customization.